Stoichiometry happens in a very predictable way, and so we can actually determine the amount of product by the number of electrons that are transferred in our electrolytic cell. So really, our electrons are acting as a reactant. We can calculate the number of moles that flow through the cell, and that depends on the current and the length of time. And so it's important to remember our units when we do these calculations, because an amp, it means that it's 1 coulomb of charge per second. And if we have 1 mole of electrons, that's 96,485 coulombs of charge. And this is Faraday's constant. So let's calculate the mass of gold that can be plated in 25 minutes. We have our amps, and so it's important to remember that our amps are coulombs of charge per second so that we can do our calculation. So we're going to start with our 25 minutes. We have to change that into seconds because of the seconds in our amps. So for 1 minute is 60 seconds. Now we can use the amps because we know for 1 second it is going to be our 5.5 coulombs. Now if we use Faraday's constant, which is 96,400, trying to round for you, 485 coulombs for 1 mole of electrons. So now that gets us into moles of electrons. So we need our chemical reaction where we see that there are 3 moles of electrons for 1 mole of gold. And we can see that from our balanced chemical reaction. Now if we want to find mass, now that we're in moles of gold, we can calculate mass using the molar mass off of the periodic table. And so we can find that our mass is 5.6 grams of gold. So for 25 minutes at 5.5 amps, we can electroplate 5.6 grams of gold. There is an alternate way to do this calculation, and the formula is IT equals NF. So the I is amps, T is time in seconds, N is number of moles, and this is moles of electrons, and F is Faraday's constant. Now this is a formula that can be used, but if you notice, that's exactly what we've done in our dimensional analysis. So we have our I, we have our time in seconds that we've multiplied, and then we've divided by Faraday's constant to calculate the moles of electrons. We've just gone another step further to find the amount of gold that would have to be done using this equation. Here's a practice for you to try to calculate the amount of amperage required to plate 2.5 grams of gold in 1 hour. Please pause the video and give this one a try. So let's start with our 2.5 grams of gold. We're going to have to calculate moles of electrons, and to do that we have to start by calculating moles of gold. using our molar mass. From the moles of gold, we can go to moles of electrons, which we get from our half reaction. So 3 moles of electrons, 1 mole of gold. Now we use Faraday's constant. So 1 mole of electrons, 96,485 coulombs. We get 3,674 coulombs, but we're only allowed 2 significant figures from the 2.5 grams. Now if we want to calculate the current, that is coulombs per second. In the problem, it told us that there were 3,600 seconds in 1 hour. And so we end up with 1 amp for our answer. Another thing that is related to electrochemistry is corrosion. And corrosion is the oxidation of different metals in the environment. So this is the rust on your car. This is the white powder on any aluminum that you see. It is the metal oxide that is forming. And the reason that this forms is because it's a spontaneous reaction that happens when the metal is exposed to oxygen. It oxidizes back to its more natural state, like the ore that it came from in the environment. And so what happens is we actually get the reduction of oxygen, and it's really easy to reduce in moist conditions. And so we take oxygen, if we have water available, that oxidizes to hydroxide. And if it's under acidic conditions, so if there's some small amount of acid present, potentially as acid rain, then this happens even easier. And so that is why we get rust on our cars spontaneously. We try to coat them in paint so that the iron that the cars are made out of isn't exposed to the oxygen. So that's why if you get a nick in your paint, why that's the first place that rusts on your car. Because our metal lies below oxygen, the metals are the ones that are spontaneously oxidized in the presence of oxygen. So how exactly does that happen? Well, when we have a small defect in the metal, it's called an anodic region. So that small defect allows a place for like a electrode, and that allows the reaction to begin. And the electrons travel through the metal to a cathode or cathodic region of the metal where the oxygen is reduced. And this could be either through acid rain or through the dissolving of carbon dioxide. If this solution becomes acidic, if it has any H+ available in it, this reaction happens even faster. So our iron will migrate through any water droplets that are present and produce this corrosion through rusting, and our rust will form on the surface. And this is a spontaneous reaction. We actually have to work in order to keep the rust from occurring. We have to paint things, we have to protect them so that the oxygen is not able to react. There are other ways that we can prevent corrosion. So one way is that we can put a coating on the metal to keep it from contacting oxygen. So if you've ever seen galvanized nails are a coating of zinc on the outside that reacts with oxygen, and it actually intentionally oxidizes so that it protects the metal. We can also paint things. Aluminum is another one that it forms an oxide layer that strongly attaches to the metal surface, and so then that helps to protect it. The reason this doesn't work with iron, why iron oxide is more of a problem, is because it easily flakes off the surface, and so it's constantly being removed and allowing the generation of more iron oxide. Zinc oxide and aluminum oxide, they adhere very tightly, and so they'll form a protective layer. Another method that we can protect metal is we can add something called a sacrificial electrode. And so the sacrificial electrode will actually be eaten away instead of allowing the iron to be oxidized. And so the sacrificial electrode will have to be replaced. And this corrosion happens even faster if we put two differing metals in contact with each other. So if you have like copper and iron or zinc and copper, this corrosion happens even more quickly. And so that we have to protect the metal.